So I know you guys may be struggling just a little bit with distinguishing the three types of electron configurations, the orbital notation, and noble gas configuration, and being able to distinguish between the three. So I'm going to work out a couple problems here. Write this down, work through it, make for sure you're understanding the process. I'm not going to use method 1 because method 1 would take way too long for me to work through and all these problems in this video. So if you need some additional help working method 1, come see me at school. We'll work through it. I'll help you out and we'll make for sure that you're getting the right answers using method 1. By all stretch of the means, you should still end up with the same answer using method 1 as I get here using my method and the periodic table. So here we're going to start with how we started in class. We're going to start it off with orbital notation. Now, this problem is asking you for the orbital notation of chromium. Okay, chromium's atomic number is number 24. So, chromium here is right there. Okay, so we're going to end up in the D block. You're going to need to expect, you're going to have to be going into the D block and the F block. And make for sure to remember your rules for electron configuration all the way through. Don't forget all the rules we've talked about. If you remember your rules, the Aufbau principle, Pauli exclusion principle, and Hund's rule, then you're golden. You're good to go. You'll be successful if you can remember that and the field order that went along with it. So make for sure, if you need a refresher on that, go back to the earlier videos and watch them, get a refresher on that, make for sure you're ready to go. So let's start with chromium. And the important part is remembering that orbital notation is the notation that has the dashes and the arrows. So we're just going to start working through with it. So let's start. I'm going to have to start up here up top, and I'm going to go to the 1s. Why? It's the first row, and we're going to have it completely full. So 1s, make sure my arrows are drawn up and down, showing opposite spins. Then from there, we know we're going to go for 2s. And then from 2s, we go all the way over to the P block. In the second row, we know that we go to 2p. So 3 orientations, and we know that it's full, so there should be 6 electrons in there. So here's the first, the second, the third, the fourth, the fifth, and the sixth. Then after 2p, we'll be going to 3s. So 1 up, 1 down. Slide this in a little bit. Now after 3s, we're still in the third row, but we're going to the P block. So third row, P block, we're going to 3p. So 1, 2, 3. Why did I put 3 dashes there? I did not put 3 dashes there because of this number 3. I put 3 dashes there because of it being a p orbital. Okay? So P. Remember, at all costs, S has 1 orientation, P has 3 orientations, the D has 5 orientations, and the F has 7 orientations. And you must show every orientation. Okay? So continuing on, we go all the way through 3p. It's completely full, so we're going to put the 6 electrons in there for the 3p. Now that it's full, we come back to the fourth row, and we're going through the 4s. So here's 4s. And it's full, so we fill it completely. Now you come into the D block, and you got to remember, what is the rule for the D block? You're always going to get the number by taking the row minus 1. So there's 5 orientations in the D block, so 1, 2, 3, 4, 5. You're going to go to the middle one, and it's going to be a 3D. How do I know it's a 3D? Because for the D block, you will always take the row minus 1, and that'll give you that number you're looking for there. Now, using my method with the periodic table that I prefer, I just count how many elements over I go. So here starts my D block with scandium. So I'll go 1, 2, 3, 4 till I get to chromium. This is where your rules are going to matter. Make for sure not to forget Hund's rule. You're going to go 1 here, and then you're going to go over to this next dash and put another one. And you're going to keep that up until you put the 4 electrons. Yes, I know that this is empty. There's nothing in there. But I still have to show it. You still have to give that representation of that orientation for us. Make for sure that's there. So you'll end up here. This is the orbital notation for chromium. You can count up your electrons and you'll equal up to 24 if you're correct. So count your electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. I'm correct. You can still check your number of electrons with using the first method. Just make for sure and be careful and make sure your math works out nice for you. So, let's go down here to do some electron configurations. Now remember, the electron configuration is this, but without these dashes and these arrows. We supplement them with exponents, even though they're really not exponents, but they look like exponents. So let's start off with a good one. Let's start off with silver, with the atomic number 47. So here's silver. Okay? So let's start off with silver. You're still starting at the top. So you'll still go 1s, 2. Now what I like to do is see where I'm going to end up at. And I like to just go on and know everything's going to be full till I get to that point. So I know everything will be full until I get to the 4D. And how I know that is silver is in the 5th row and in the D block. So I know it'll have to end up, the 4D is where I'll end up. And I'll fill all the way till then. So 1s is full, 2s is full, 2p is full, 3s is full, 3p is full, 4s is full. Slide this down a little bit more if I can. After the 4s, we go to 3d, it's full, 4p, and it's full, and then we go to 5s, and it's full. But that's where we stop with all of them being full. After 5s, which is right here, 5th row, it's full, because I go all the way through, but then I come to this point where I'm coming into the 4D. So, I come into the 4D, but I know that this one is where I'm going to have to stop. So count how many how many elements over you are and give the representation of electrons for it. So slide this over so you can see it. So you are 1, 2, 3, 4, 5, 6, 7, 8, 9 electrons in to the 4D. That means, file cabinet keeps messing me up, you'll be 9 in. Okay? So even if you use method 1 for that, it'll still work out and give you the same answer. Now let's do another one. Let's do tellurium. Okay? So tellurium, and I'm going to do this one a little faster. So here's tellurium. Alright, I'm in, where went the marker? So tellurium is right here. I'm in the 5th row. And I'm in the P block, so I know I'm going to end up with, all of them's going to be full until the 5P. So this one's going to be a little quicker. Slide this on over. Alright, so let's just start going on with these things. So let's go. I got 1s, 2s is full, 2p is full, 3s is full, 3p is full, 4s is full, 3d is full. If I'm going too fast, it's a video. You can stop it and press play again, and you can replay. So 4s is full, 3d is full, 4p, you guessed it, it's full. 5s is full. 4d, it's also full. But now I get to the 5p. My 5p is not full. I go in and I look at my periodic table. Here's where my P block starts in the 5th row here in Indian. So 1, 2, 3, 4. I'm 4, looking to go 4 in. So that gives me 4 electrons I have to represent. So it's 5p4. Okay? If you have any questions on the electron configuration, come find me at school and we'll talk about it. Now, let's go to this noble gas configuration. I know that some of y'all were having a lot of issues with this. Don't make it hard. Well, don't make it harder than what it is. Okay? Just come to your periodic table. Your periodic table will not be this big tomorrow. Okay, so let's go. I picked 2 good ones. I picked 2 hard ones for us to do. They're 2 really good trick ones. So the first one we're going to do is lead. Lead is right here with the atomic number 82. And this is what you do to find, what you will do, you always do this to find the noble gas you'll use. Point your finger on it, go up a row, and all the way to the noble gases. And you'll see here that I'm using xenon, atomic number 54, to fill in for a whole bunch of stuff and make this shorter for me. So xenon, so put it in brackets. Do not put it in parentheses. Put it in brackets. And then do your electron configurations from there. So from here, I go from xenon, which will end in a 5p. So I start here with 6s. And this is why it's a really good one. You got to remember after you go through the 6s, you have to come down to this lanthanide series and go through the 4f completely. So we'll completely go through the 4f. It'll be full. So it's 4f14. Because an F orbital will hold 14 electrons. And then we'll come back up here to the D block. Now when we come back up here at the D block, it'll be the 5D. And it is full as well. I know that because lead ends in the P block. So I go on down and I can see that I'm in the 6th row in the P block. So I know I'll end at 6P. And I look how far in I am on that 6p and that here in the p block. So I start with thallium. So 1, 2. I'm 2 in, so it's 6p2. So you get xenon in brackets, 6s2, 4f14, 5d10, 6p2. Now let's do another one. Now this is an easy trick to mess you up on. It's giving you a noble gas to start with. Okay, so we're going to start with radon, which is the very last noble gas we used to have. So atomic number 86. Just do what you've done before. Put your finger on radon, go up. You're already in the noble gases, so you're going to use xenon again. So xenon, in brackets again, and it's going to look the same as what we have for lead. It'll look the same for what we got for lead. So 6s2, don't forget the F block. You have to go back through that F block. 4f14. Come back to the D block. I go all the way through because I end in the P block. So I know it's a 5D, 10. Okay, so 5D, 10. And then you go all the way through that P block. So it'll be 6P, 6. Because you're in the 6th row and you're in the P block and it goes all the way through to that noble gas radon. Now, don't forget, I mentioned this rule, I just thought about it. I mentioned this rule for the D block. Don't forget how I'm getting this number here for the F block. The F block, you'll get the number for it by taking the row minus 2. That's how you get that number for the F block. And remember, if it helps you, remember this lanthanide series goes up here in this 6th row, and this actinide series will go in the 7th row here. So just remember that this lanthanide series is row 6, and actinide series is row 7. If you got questions, come find me at school. I'll be happy to answer your questions, and you guys are going to do wonderful.